Hello, everyone. Thank you for joining our XCamp Robotics fall class info session tonight. I'm Janet. I'm the host for the session tonight. We have a packed agenda. So first, Mr. Chen will give us a quick overview on the philosophy of why we're teaching the kids from K to 12th grade robotics, and what are the research areas for this class. Then we have Yichen here, who's going to give us more details on our first class Robotics 100, the class introduction. And also we have a special guest here who's going to give us a demo and show her experience as a current student, how she feels about this class. Then after that, we will ask Mr. Chen to give us an overview and introduction on what 101 class will be covered in the coming fall, and also give us a future class overview. After that, we'll have Q&A session. With that, I'll hand it over to Mr. Chen. So please go ahead and start it.
Okay. Thank you, everybody. So I think that I want to deliver some key message. Number one is so the philosophy for us to teach robotics, actually this is not just robotics. This is about anything related to robotics, about design, about control, about programming, about the classical control, and then most recently I've been learning-based control, like use AI to do the control. So the key message I want to say is another our kids more advanced. So another student in the high school, they start to take AP level class. So we had the same kind of philosophy. Let's teach our kids how the university students, how they learn robotics. So that's our key message number one. And then key message number two is I have been the robotic coach from when my son was third grader. So, and now it's he's going to 10th grader. So we have been doing the he had been doing robotics for 7 years, and I'm his coach. I observe he spent a lot of time. So when you have like a 15-week semester, then every week he probably spends between like 5 to 7 hours. And when you get a competition, it's even more hours. And I look how many things he really learned from robotics in the high school, in the middle school, from elementary, middle school, and high school. The amount of effort, time he spent, and the amount of what he really learned from the engineering point of view, technical point of view, is very little. Compared to time he spent. So what and as a coach, I always want to teach them some more, some domain, really what I know about robotics, about research, about my experience. But we never get to the point because if you have kids who do the robotics, you spend most of your time, you do the engineering, do the design, do the mechanical, build the robot. By the time you really want to do something coding, do some programming, do some advanced control, something, you don't have much time. You only have 1 or 2 weeks, 3 weeks before you get a competition. So that's so that was really troublesome. And also, I have another conversation with our high school students when then I in the robotics. I said, how the robotics help you to get to top school? And most people said, robotics is not something really help me get to the top school because it's a team type activity. So it's hard to highlight how much your contribution. Because everybody can say, hey, I'm the leader in the team, and the team went to the 30 award, but that's a team award. So that's another thing. Number two. So I really wanted I wanted to figure out a way how to teach our kids, really learn some engineering, then learn the robotics, how the college teach the kids. So actually I spent last since 2018, I've been taking classes in the Stanford University, every single department from computer science, electrical engineering, mechanical engineering, aerospace, statistics, every single class, anything related to robotics, I take class. So I take about almost 17 class, anything related to robotics. So I was thinking, hey, I learned a lot. So I like to take what I learned, and I want to teach that to the student. That's what we experiment this summer. So we teach the kids. We take some saying the ROS, which is Stanford teaches undergrad. Now we try it out, and it surprised me. Our kids can learn what Stanford teaches the university students. And some are amazing students, even like a sixth grader. So Rory is one of our students. She's from a sixth grader going to seventh grader. And she learned what we teach in the Stanford University. And she learned everything, and then she mastered that. And I was so amazing. So what I'm trying to say is it's doable. And I was so confident now that we can teach the students, middle school kids, high school kids, how the Stanford, how the top school teaches the university students. We just need to customize that. So that's our main motivation. So we like to have our kids to build some sort of foundation on the engineering, really know something or the different major, different field. So they know, they can think about what my future, what I'm interested. Right, and then they think about, so when by the time when they apply for the college, then say, here's my essay, what I want to do for my future. So that type of essay will be way much more interest to the college who review your application. So that's one of the goal we want to achieve. And we're not going to teach our students the professional tool and the methodology, how we do that at work. I think Yi-Ting will highlight that in our teaching. And we like to use, so a lot of our students is at campus students. So we want to teach the kids what you learn in that camp or the algorithm, how that applicable to the real application, real world use case. And then you can see that how algorithm make a huge difference in the simulation environments. And all things we teach the kids also can help the students to succeed in the robotics competition, because the methodology we teach a much higher level. But in the PID control or the algorithm, you will need to use that for the high school competition as well. And we really want to get our students think about, have the critical thinking, start to learn the state of art methodology, and prepare them ready for the college application, or also think about for the future career, which path you want to choose. So that's really our motivation. So this is the key, what we see the main area for robotics. So in this summer, we teach the blue box on the right side, the we XP100. So main thing we teach the kids how to a lot of information about I think Yi-Ting will talk about more detail. I think the highlight for the summer class, the entry-level class, is how you use the PID control, how do you control the robot use sensor, how to use the color sensor, how to use distance sensor, how to navigate the robot. So the main on PID control. So in the fall of the class, we are going to teach is about the use LiDAR sensor, how to figure out the distance, and then how to use that information to build some map for the house, for the interior structure, and also use camera as a sensor to take the image, and then kids can use neural network AI to do the object detection to figure, is this so if they take an image of the house, is this a table? Is this a chair? So that I'm confident that even for kids in the middle school and high school kids, they can use AI, use neural network to do the object detection. We can just talk about the very intuition, how the thing works. You don't even know the gradient descent or the mathematics behind, but we can just intuition tell them, hey, how this is how it works, and then they know how to use that AI to do the object detection, and then we'll move up to how to do the localization, how to build the map, and then how to get a global map. So you have the local map, how to build a global map or the relationship. And then when the kids want to get the 10th grader, then we'll learn statistics. There'll be a time we can teach the probability and uncertainty, random process. And how do you make a decision under the uncertainty, make an optimal decision? And then continue forward, you can learn, kids can learn that reinforced learning, how to let the robot agent to learn the policy through the play. So once we finish that, there will be completed most robotics class in the university, 4 years class, anything related to robotics. So that's a key framework we want to teach the students.
Thank you, Mr. Chen. Like I said, thank you for the vision and why we want to do this class. And let's go to the next set of the agenda item, which will welcome Yi Chen, who's going to be our instructor for the upcoming fall class for 100. We will have 2 classes for the fall, 100 and 101. Mr. Chen will, if you're not talking, can you please put yourself on mute since this is recorded? So like I said, Mr. Chen will continue teach 101 and 100 will be taught by Yi Chen. And let's welcome Yi Chen to give us an introduction on how this class will be taught in the fall. Go ahead, Yi Chen, please.
Yi Chen, you're on mute. Somehow Yi Chen, I cannot hear you.
Can you hear me now?
Yeah, perfect.
Yeah, we can hear you.
Yeah, all right. Sorry about that. And hi everyone. I'm Yi Chen. So I will be teaching the XB100 class in the coming fall. And the first thing I want to talk about is that the learning robotics is really hard, as I experienced as a captain in my high school robotics team, and also as a student who worked in many research labs working on robotics. I can see learning robotics is very complicated and very difficult for even like fourth year university student or graduate school student. What makes it really hard is because it's very hard to configure the development environment, especially like when we're using Ros, the industrial standard tool. We need to control the version of the Ubuntu system, and we need to control a lot of things. And this thing makes learning robotics on our own very hard and complicated. And the second thing is robotics have a different programming model from our day-to-day other programming. So to understand the programming models and how the messaging pattern works is also hard. And third is to process sensor data. As you know, sensor data collects at the millisecond level. So we have a lot of data coming in. So we have to use some big data processing method and apply algorithm. We need the algorithm to be fast, and we need the processing to be fast, which is also hard. And the fourth one is for most robotics applications, we need to have the hardware, and it's not like just writing a hello world in the programming language. Purchasing a hardware will be pricey and will be more difficult. However, can we use simulation though? But this comes to the fifth difficulty, which is simulation nowadays for the robotics applications is very difficult to use. So overall, I think it's kind of hard for regular students to get into robotics. So that's why we designed this course. So the first goal of this is we want to get students into robotics at the very minimum difficulties, and we want students to fall in love with robotics, because I personally is very passionate about robotics, and I know how beautiful, how elegant it is when it's working, but to get it from nothing to working is actually very challenging. So we will try our best to help the students to get into this and fall in love with robotics without all the obstacles, without all the difficulties, but just fun and knowledge. And the second is we really want to teach industrial standard or academic standard skills. We don't want to build like toy projects. We don't want students to learn something and they can have fun now, but they will not be used in the future. So a lot of robotics classes designed to teach students like very easy projects, and they want them to have like maybe a easier way to get into this. But later they will find out when they start using Ros, when they start going to internships, they go into research, they will figure out it's actually totally different from the toy projects they used before. And this is one big steep learning curve from the students to actual using it. And that's why we designed this course. We want to teach the widely used academic and industrial standard robotic skills. So we don't want the students to learn something that are not going to be used in the future.
Great.
All right. So yeah, I will go into the details of the thing. So the first thing I want to introduce is the XB100 stack. So the XB100 stack will have the industrial standard tools. Like we'll help guide students through setting up environment in Google Cloud platforms or other cloud platforms such as Microsoft Azure. And the student will learn the basics of Ubuntu. They can, in the end, they should be very confidently navigating through Ubuntu and running commands that builds the software and runs the software. And they will learn a basic of Git version control and the GitHub platform. So that's very big part of the open source community. And that's, if you know about the software development, it's pretty much the golden standard for the software development tools. And student will also use VS Code to write the code for the robot. And at the end, and the very most important, student will be introduced to robotic operating system, the very standard tool for the robotic development these days. All right, next slide, please. All right, so for the first thing is we will go through some overview of some robotic terminologies and some very academic formal robotics definitions, and including degree of freedom and some mechanics, and also some other important terms and the knowledges that student will be able to use later when they describing what they are doing or when they are writing a research paper. They will definitely find these knowledges very important. And also we'll introduce a very important, very widely used popular industrial standard simulator called Copolia Sim. And the student will be able to use this simulator and manipulating the robot arms, and they will understand the very basic of the how we control the robot and how the robot works. And they will also combine the terminologies we taught earlier into. All right, next slide, please. Yeah, and also we will introduce a pack of sensors and actuators to students. So when in the future you are the students are doing FTC, FRC, FLL, or VEX competitions, they will figure out if they have a lot of sensors and actuators at their disposal in their toolbox, they will have much more possibilities when they are designing and constructing the robot. So here we want to introduce a set of sensors and actuators to the student. So in the future they can use them freely, and they can take the leadership in their robotics team or in the research when they are designing the robot. And in this class, we'll be focusing on in this particular XB100 class, we'll focus on the distance sensor and camera, and also motors and also the line following, like infrared sensors. Next slide, please. Yeah, and also the most important thing is we want to introduce this programming model to students by using Ros. So Ros is a tool that's constructed through the logic, which is called a publication and subscriber model. So if you are familiar with big data and streaming processing, you will know like tools like Redis, Kafka, or RabbitMQ. They all use the same publication and subscriber programming models. So Ros is having the very similar idea of controlling the robot with this pub/sub model. So by introducing and let students practice on this kind of programming model, in the future, whatever they are doing in the industry or in the academic, in whatever internship when they are handling data, they will find it very helpful because they are already understanding the programming model of this. And by using this programming model, we make building robotics and handling the sensor input and output to the actuators very straightforward, because everything is be centralized in the master, and all the other peripherals will be controlled through this messaging system. And in this class, we will help students to build a we'll help students building around Ros, and we'll have sensor input from distance obstacle sensors, infrared sensors, and we'll let the message queue output to the motors and the controllers, drivers, something like that. All right, next slide, please. Yeah, so here comes to our very end of the course, and the student will be working on a final project that's a line following robot that we call it a race, because we want the students to compare how fast they can run the robot, and they will have a little bit gamified way of learning, and they can learn by competition, and which is very fun. And by doing this final project, student will be introduced to the very basic of the PID control. So which, if you are familiar, it's a very important controller for the robot control. And we will, by teaching PID control, we will simplify the very complicated integral or differentiate mathematics, but we want to teach the student the very basic and the big picture of this PID controller. And we will provide them with the simplified mathematical expression, and they will implement it with their own coding, and they can see it at work at the simulator, which we use Gazebo here. And by learning this, when later the student get introduced into calculus, differential equations in either high school AP classes or college classes, and also when they learn control theories in the university classes, they will have a much better instinct, because they already can see what it is actually what they already built before, and then they will learn much better than if they don't have any previous knowledge before. All right, so hopefully this can this is helpful, and our student Rory will also give you a demo on this on her line following robot project.
Thank you, Yichen. Yeah, I know by now, I think the parents will feel, wow, this is a great class. There's a lot to be covered, but can the kids absorb it? How hard will that be? I'm very happy to see during the summer, all the students we have, they really enjoy. At the beginning, they struggled. After a couple of lessons, they all really enjoy and like it. So today we invited Rory, who is a current XCamp student and also our current 100 class. So she will tell a little bit about her experience as a student to this class, share that with the parents, and also do a demo with the course project. So Rory, before I hand it over to you, which grade are you right now?
I'm going to 7th grade next year.
Wow, 7th grade. So let's hear from the 7th grader, her experience, how she feels about our 100 class. Go ahead, Rory.
Okay, so hi everyone, I'm Rory, as Miss Lee introduced, and I'm going to talk a bit about my experience with the robotics class. And I think the main thing that this robotics class taught me is about robotics in general and why it's important. And I think that was really cool because I've learned about robotics before, but this really introduced me to the impact that robotics is making on the world and how it's like shaping the future moving forward. And that's what got me inspired into continuing this robotics class. So after we learned about the importance of robotics in the real world, then we started by learning how to use various simulation programs such as the Coppelia Sim or the Gazebo. And then in conjunction with VS Code, we were able to run programs that allowed us to do simulations. And actually Gazebo is what I'm going to use to show you my demonstration today. And then we also learned about the ROS system, and it's basically the system that controls the robot. And we learned about the various functions of the TechSpot, which is the robot that we use to run simulations on. And so after we learned about this basic information on how to operate robots and run simulations, then we were able to do hands-on exercises that allowed us to practice writing programs in order to actually control these robots. And this class was really important because it taught me how to think creatively in order to solve the problems to create these programs. And it's always really gratifying when the code works and it produces a result that allows you to learn more, and it's actually successful and reaches the target. And I think this class has really inspired me in general about why robotics are so important and what they can do for us moving forward as the world becomes increasingly digital. So I think this class is a great introduction overall to robotics and how to use robots.
Thank you, Rory. And I know Rory is going to give us a demo on, this is our current, one of our course project. I know we have a final project, but we haven't, because the class is still working in progress. But do you mind to show us this demo? Like, you can take over control. Let me stop sharing. You can go ahead and share it.
Yeah, so I'm going to demonstrate one of our class projects that we did last week. And so this project is where we have a robot on this black racetrack, and the goal is to have the robot move around the racetrack without leaving it. And so I created a code for this, and using the Ros application, I can run this code. And we can see how it runs. So the robot is moving forward on the track. And basically what I did for this program is that there is a sensor on TechSpot that splits into 8 segments to allow you to see the color index of part of it. So then I can check if the color index is black, then I can see where on the 8 segments is it. And then if it's really far to the right, then I want to turn to the left to avoid that. And if it's really far to the left, then I want to turn to the right to avoid that. And so as you can see, the robot is making corrections when when the black gets too close to the end of the robot, then it turns. As you can see, it's not very smooth because this is the basic approach to doing the racetrack, where it just corrects for the path. And as you can see here, when it creates a turn, it keeps turning until it gets too far off the track, then it corrects itself. And so basically this robot is instructed to just, as long as it's not too close to any edge, it just keeps moving forward. But if it's too close, then it will turn. And as you can see, it's able to follow the path of the racetrack pretty well. And it can make it to the end of the racetrack successfully. Yeah, okay, so that's basically the demo program that I had. And now I can explain the code really briefly. So So I wrote this in VS Code, and basically what I had is that the read line sensor is basically it has 8 segments, and for each of these 8 segments, it has one number. And if the bigger the number is, that means the darker the color is. And so what I did is that I sorted the value of these 8 sections. And then I said, if the bigger numbers are to the right, then that means that I should turn left because the black is to the right. And so, I should turn to right because if the black is to the right, then that means I need to turn in order to center it again. And if the black is too much to the left, then I should turn left in order to center it again. So using this concept with some simple if-else logic, we can create a code that will allow the robot to move around this racetrack.
Thank you, Rory. Let me share my screen back. Where is it? Can you see my screen? Okay. Like I said, this is one of the projects, not our final project. I'm so excited for the final projects to be finished. And we will have another presentation. We'll invite our students to come back to do a demo for the final projects. And we'll share that with all the parents. I really appreciate your time and to show us like this class can be taught to our middle school students, and they took it very well and they really enjoyed it. It is a lot of fun for them. This is the best rewarding we got as teachers, that can see the student write the code, make it work, and really have fun with it. With that, we'll go to the next part. Maybe Mr. Chen you can tell us a little bit about the final project, but
Okay.
save the fun to the final demo. Do not give out too much.
Okay. Yeah, I think that what you can see, our teaching methodology, just like when we do research, I always ask the student to do a baseline. I said, I'm not going to teach you and I need you to try it out with this the robot mission, do yourself, like what Rory did. We had not teach her how to use PID controller yet. I would say, before you do the PID control, I want you guys implement most naive algorithm you can figure out how to finish the mission. Then you can see the Rory, the robot drifting around, but she get the job done. Very simple algorithm, she finished the mission. That's what we call the baseline. And then we will teach her how to use a Pid controller. And then she will see, hey, there's some improvement. My robot can go in more straight, not drift around. And then we're introduce D controller with the derivative. You can predict for the future, make your robot control even more smooth. And then we, on top of that, we introduce the I controller, which integral will be reduce the steady error. So that's how we to continue. Every lecture, every lab is built upon the lab we had before. So it's as Ethan said, we are trying to put the course together. It's incremental, so that make the learning very easy. Incremental learning very easy. And then we running like I think that what I was amazing is this summer class is very tough. Some of the parents said, hey, this class is not only hard for students, even hard for me as a parent. Sometimes I even don't know how to help. Some of my friends who is engineer do. But I was surprised that most students probably will drop or can stop, not can register for the continued class. But a surprise to me is everybody continue on and learn the next class. As what Rory said, she get over all the difficulty or the problem, and then she get over and found something working. That's more what she feels certification. I think that's just in real life. When you really solve some hard problem and then you get it, that's where your joy come from. That's what I wanted. What we want to teach the kids to, when some problem is broken, we want to make sure they be calm. Hey, this is like one student and a parent tell me, hey, 陈老师, we built the Ubuntu 5 times. I tell them, even for me, even I'm a professional, I built the Ubuntu 20 times. I'm 4 times more than you did. The reason why I want to go through all the different setups so I know where the problem can come from. So I just want to make sure our kids learn. At engineering, sometimes you need that stemma to solve, to become, when you have some issue, you try to fix the issue. That's how you learn. I think through this class, our students incrementally solve another small problem, small puzzle, big problem, big puzzle. That's how you learn. So that's for the final project. So that's what it is for the car racing. So then we're using PID controller. For the track, they want to finish in 30 seconds. That's minimal. Everybody must pass the 30 seconds to finish the whole track. And the full is use the fewest time. We're ranked by the time. If you use faster, will win the race. But minimal, everybody must finish under 30 seconds. So that's our final project. It will be fun. You have to use a PID controller. So next naive algorithm with the Rory demo today is not going to make the final project because you cannot finish that in 30 seconds. You have to use PID controller. So that'll be final project. It will be fun.
Thank you, Mr. Chen. I know we only have 20 minutes left, and I want to at least have 15 minutes for the Q&A. I'm sure parents have a lot of questions. So we covered a lot about 100. Hopefully that give a good understanding on what is 100 is going to teach and how it is received by the current students. Let's talk a little bit on the upcoming 101. So Mr. Shen, can you give a quick, like maybe 2 minutes introduction on 101, please?
Okay. So as I talk about our philosophy, we are build the class incrementally. So the students continue to learn, and then what's the next, then the next will be based on what they learned before. I think in the summer class, XP 100, the student learned the distance sensor. So, and then I remember in the last week session, student asked me, hey, I have 2 distance sensors, left, right? How do I use that? How do I use both sensor, right? So we teach the kids how to use that because the 2 sensor, left sensor angle 45 degrees that way, right sensor angle 45 that way. You can use that 2 sensor signal to figure out how to make the more intelligent decision. And then for the mission, what the Rory demo a moment ago, is called array sensor. Array sensor, that means array of 8 sensors. So you have 8 signal. And how do you use that information? What Rory did, she used sorting, found what's the maximum, and from the maximum make the decision. So that will be your error signal. You use an error signal to do the PID control, right? So when you have a lot of sensor, how do you use that information, make a decision, right? It's all about make a decision for the robot control. So the student learn about the utilization of the distance sensor and then a camera. And then in the XP 101, we will teach the kids much more in depth about how this camera sensor work, how the distance sensor work. And then how do you, as engineer, how to solve the, what you can talk about is when you have the big volume data, how do you deal with it? Because your processing power will be not much slower than the data come in. And how do you deal with that? And then when you have a lot of sensor information, how do you fuse all the information, make a better decision? Now, sometimes the sensor has a noise, signal noise. How do you deal with that? And then, so when you get a raw image, and how do you process the raw image? Because the image, there's no information, just look image. You need to do the image processing. That's the first module we'll talk about. How do you get the edge information? And then you extract the shape out of the image. And then from the shape, you can figure out the object detection. That's one traditional way to figure out the object detection, shape extraction. And we also will teach use a neural network do the object detection. You can easily download a model and then use our model, training model, and then do the object detection. So we'll have a module to talk about that too. And then we're using LiDAR sensor to figure out distance and then use that to figure out localization and how to do filtering, how to do the shape extraction. So that will be very fun class. So this the full class will probably most fun class because the kids will be like the play image. You can detect the cat, detect the dog. That'll be a very fun class. So
Thank you.
that's for the one-on-one.
Yeah, looking for the fun class in one-on-one. And one more question for the future classes. I know you covered at the beginning, but on a very high level, after 100 101, what other classes in your mind that will be able to offer to the students?
So I think the kids learn the PID controller in the 100, and then from there, I think we'll learn more about the in the future more advanced control theorem. So often you have a different type of controller. Sometimes you have the trajectory control. And once you especially for example your vacuum cleaner, right? When you do the clean job, that's one controller. But once you then finish the go back to charge station, there'll be different controller. That's often called post control, because you need to figure out adjust the control, insert orientation post, very critical, so that the robot can go back to the base, can fit exactly get the chart, because the post control will be much more, it will be different. For example, we're teaching about how to do the post control. And then I think the one of our current student, he's a student CS 600 level. He's asked me, hey, can we use the search algorithm? So some students were learning in the CS XCAM class, like A-star algorithm, something we were teaching in the robotic class. There will be more advanced what you learn in the XCAM class. RT, very state-of-art robot control, motion planning. And then we were also for the control, we were teach a state machine. So that's more advanced controller state machine. We also were teaching the sampling-based method. Not all the engineering you have to solve the closed form solution. Sometimes you can use sampling-based method. We are teaching more advanced information extraction and how to use object recognition. And then when the kids get to 10th grader, 11th grader, we were then once they learn the statistical stuff, we were based on that can teach the student about the Markov localization, talk about random process, and use EKF, some filter to the localization, and part of the autonomous vehicle actually part of the robot. So I think in the future we will also talk about autonomous vehicle mission control. And partner will also talk about drone. Drone is a kind of robot too. So drone will be something we are interested to teach the kids too. All right.
Okay, that's it. One more slide. Let's get into the Q&A quickly.
Yeah. So there are a lot of students and kids. Even last week, the student William to ask me, "Hey, when we are going to work on real robot?" So what I'm looking for, this is like a turtle bot. This is a robot at Stanford University use this type of robot. So this is like about $1,500 kind of robot. Had a lot of sensor. They have the LiDAR sensor. They have the use a Raspberry Pi controller. They have the camera. So this is way much more expensive than the vacuum cleaner robot you have in your house. So we plan to buy one in the San Jose, buy one in the Austin. So the students will form a group, and then we'll do the program, do a simulation on ROS, and then once the simulation work, you deploy the code into the robot, and the robot can do the mission. So that'll be our plan. So that eventually, once the serious simulation build the foundation, and then we will deploy and try it out on the real robot in the future class.
Yeah, it looks very fun. Looking forward for the turtle bots, but it's not going to happen in 100 102. This is more for the near future after the student are mastered in the programming in the simulation environment. Okay, with that, let's see. For class registration has started. So just a very high level, I think some parents in the Q&A session already asked, it's a 12 weeks weekend online class, the same format that we have been doing for all the XCamp class. And the price is, we try to make the price affordable for, all the states. So it's going to be 800 for both class for now. And we, like I said, for the coming fall, we'll have 2 classes, 100 introduction to bots and 101, which is bots vision and LIDAR math. Yeah, so those are 2 classes is and with a scheduled time, and also the registration form is listed there. And with that, on the right side, on the left side is a registration form, and on the right side, we did today create a XCamp robots parents group in WeChat. So that way we can, one more channel for us to stay connected. Of course, we can do email, and we'll have classroom started in the Google Classroom. As soon as we have enough students, we can start a setup. With that, let's quickly go to Q&A. We have at least 10 minutes. Let me go to the chat to see if there's any question that already be answered. And at the same time, feel free to unmute yourself. You can directly ask your question to the teacher here. Otherwise, you can feel free to type in the chat. I'll read it out. The next one. So what is what do we need for 100 class? So there's one slide on that, but Mr. Chen or Yi-Chen, can you just quickly summarize what the student need to be able to take 100 class?
Yeah. You mean the hardware, or like you mean the
No,
hardware?
like no, like it's
the
more
prerequisite.
Yeah,
Okay.
there's one slide on that, but I believe they, correct me if I'm wrong, you need to have some programming background. So if you're in XCamp class, we're looking for you are a student who's in 102 at least, then you will know either Java or either Python or C++.
Maybe maybe I can answer that question.
Yeah, please go ahead.
The student need to be at least know one language. So for the robotic class, we teach the students program both Python, C# at the same time. So in our we think that Python and C# is the best combination, 2 language. You need to know both. So all our teaching from XP 100, 101, we will continue to teach both use Python and C++. I think 100 will primary use a C++, but later when we use learning base, another will be shifted to Python again. So for the student who only know the Python, don't know the C++, at the beginning, I have this some self-study guide. You can go through, and there are video, there are homework assignment. You can help yourself. And most of our students who, I think there are about 10 students in summer who never learn C++. So they only learn Python. So then learn the C++ themselves. And through the lab, we teach them, continue to correct them the grammar on C++, and then they can keep up. So yeah, as long as you had 1 year solid programming experience, you should be fine. Right? Because robotics is not more about domain, about learning the robotic domain.
Yeah, I just want to add on based on the current students base, like we have students who have been already in XCamp 600 and series, and also we have students who are just 100 series. Like they come in with different coding background, but as Mr. Chen said, as long as they have 1 year solid coding experience, they both enjoy and learn, because this is robotics is a different domain. They will learn a lot for the robotics itself. And I think that also come to the second question, the programming language. I heard that students are doing coding for the 100 class using either Python or C++, and also they switch and miss. mixed during the coding session. Is that, do you want to add more to it, Mr. Chen?
Yeah, I think that for the 100 mainly we use C++, and there's some concept we demo use Python. We even use a Jupyter notebook to demonstrate some of the use Python code to demonstrate the concept.
Okay, thank you. So this parent said, yeah, it is C++ or Python. So, and we do have a free learning on how to learn C++ for students. Learn good enough about C++ for this class. The next one, okay, I think each already answered that. Yeah, so if, of course, if you are taking, okay, so is that ended? So, okay. How do we make online robotics class interactive? So who wants to answer that?
I think that we so our class structure is like 2 hours teaching session and then 2 hours of lab session. So especially lab session, we are very interactive because we like to have the student demo his or her mission and then demonstrate and then demo the code, and then we will give the feedback individually. Actually, we in a group together. Sometimes the classmates give the feedback, and I think it's very, very interactive. And then we also give the correction feedback. Hey, how you can improve your code? Because every student, the solution comes its own unique way. And we are very encouraged students come with own solution. And then we follow the students the method. We will give the feedback how to continue to improve. So it's very, very interactive. We give the personal advice for every mission we are doing.
Okay, yeah. So like, I just want to add on, like, the student Rory just demo, right? She showed her code and she demoed the code. So that is the interaction that the class did that for all the in their labs. That's how they interacted with each other. They debug the code for each other together with the teacher and TA. So it is very hands-on, very, very interactive, and you can see it. So the kids can really enjoy and help out each other. So the next question, where are the schedule of the offering? Yeah, so it's here. And I think I showed in the last slides about the class information. I'll paste in the chat window as well with the schedule and the price and a link to the registration. Yeah, okay, thank you, Yichen. You put it there. The next one, does a student have to take 100 before taking 101? I think that is best practice, but every rule have exception. So Chuanqi, do you want to see, is it a must have, or we do have exception for students who might already advanced?
I think that for the student who want to take 101 without take 100, I need to give you an interview phone call with you and the parents, and then and also you need to I have some documentation getting you to prepare because I want to make sure everybody on the you're not too far behind. So you need to put some work to the preparation so that before the I think the probably 2 or 3 weeks of work to get you ready to prepare. So I will say, talk with me, we will do the phone call, and then I will get you ready. If I think you are doable, then there's some work for you need to catch up. Like how to install ROS, there's some basic information, some lab I want you prepare, catch up, and some recording I can give you to catch up with that. So really, just talk with me, and then we will get it prepared if I think you can get it.
Thank you. And what are the different age groups? I guess that there's a big age group gap. It's not how old are you, it's more like if you have a solid coding experience, and also do you have passion about, like, we do have the students from 6th grade all the way to high school, and they all learn it. At the beginning, it's a challenge for all of them, but after a few classes, they are all really catch up very, very quickly and nicely. So Chen, Chuanqi or Yichen want to add more to it based on your teaching experience?
We have actually this summer class, we have very diversified background. We have students who take the XCAM CS 102. We have students 200, 201, 202, there are 300. There are students even CS 600. It's very, but when you learn robotics, you are on the same starting point. Everybody's same. There, you know what I mean? When you take a CS2 600, you are better than CS 100, 102 student. The student who just finished 102, then put effort. They might do better than you. I think Rory is just a sixth grader, just finished sixth grader. She's going to seventh grader, but she's one of the best students in the classroom. Really depend on how much effort you put into class. It's age doesn't make much difference actually when you learn the robotics right now.
Okay, thank you. But we do want at least you be sixth grade in the middle school, because it does require you know how to code to be able to take advantage of this class. I just want to make sure this is not for elementary school students.
Yeah.
The last question in the chat window, who are the teachers? And you're correct, Henry. Yichen will be the instructor for 100, and Mr. Chuanqi will be teaching 101. Right now, Mr. Chen is the instructor for 100, and Yichen is the TA. But really, Yichen has been going into every single class, including the lab and class, so he is ready to teach 100. So Mr. Chen can build 101. That's why we have both teachers here today for the info session. In case parents have any question, you can ask the teacher. And that is all the questions I have in the chat. So we are 1 minute over, but I'm okay with another 5 minutes. In case any parents have any question, please feel free just to ask. Unmute yourself and try to ask the questions.
The topic seems to be really deep.
Yeah,
It's a lot of very professional, I think, university level kind of a knowledge.
yeah.
But from your experience, how much do you think the kids, especially the young kids, will understand the knowledge that you taught them? Like this is I don't know. It just seems like a really deep, even for parents, for adults who've been college educated. If it's not in the CS major, maybe some of this classes can be really hard.
I mean, I think that if I look back my my study and the career, I know like a random process. I learned it 4 times. The first time I kind of know some concept, but I really didn't get it. Only like 4 times I learned it, but it doesn't my first time when I learned a random process is useful. I think it's considered useful. So I think that for like this summer when we teach a student, for example, what does it mean degree freedom? What it means the homogeneous transformation matrix, and we use the simulator so that student when then moving the robot arm around, you can see the homogeneous transformation matrix change. Then you can see the robot and the effector, the trajectory, the task space move change, right? So I think that with that, the student build some intuition. Oh, that's how it works. That's what the terminology, what means degree freedom. The disk moving in the 2D space, and then that's 1 degree freedom. In 3D space, and how much constrained and unconstrained, they can figure out. I mean, some of the concepts actually students did get it. And when you look at what Rory demonstrated today, you look at that, I was amazed by she know how to use Ubuntu. She type everything in the command line herself, write code of VS Code, know how to save the code. And then first time student use a professional tool, they always forgot to save the file, then just compile, right? You need to save the file, you compile, you build, and then you execute. And then I was amazed that student can get it. So I really, in the summer, before we start the class, I really don't know if this is going to work. But after summer, when I see so many students really can get it, I was really encouraged that this is going to work. I mean, I'm not talking about students really want to get to the 100% the deep as university students, but we were simplify the way the student has like an introduction. They know what is going on, what is from mechanical engineering robotics, what is from electrical engineering point of view, what is about robotics, what about statistician, what about computer science, what about from AI, different perspective, then learn about robotics from all different fields. Then they may find, hey, I like computer vision, I want good computer science. Hey, I like the control, I want to do the autonomous control, I want to E department. And maybe I want to just design the robot arm, figure degree freedom, figure task space. I'm going to mechanical engineer. So I hope that can, that's our passion. We want to get our students to think and what they want to do for the future. Once they build that interest and motivation, your kids, you don't worry because they are on a mission. Don't need you push. They will push them themselves. That's what I consider Rory, kids like Rory. You don't worry about kids like her. She is very, very self-motivated, right?
It's not only about like kids like Rory. I think what I try to see is don't underestimate the kids. They are fearless at this age. You teach them things as long as in the right way, they will take it and they have no fear like, oh, this is not something at my age I should learn. As long as it's interesting, they will learn it, they enjoy it, they'll keep learning it. So with that, I think this is a great question. Yichen, what is your input as been teaching in the summer for the class? How did we find a way to turn the complex subject into a simple and easy way that the kids like it and learn it and continue with it? What was the magic?
Yeah, I think the most important part is we, especially Mr. Chen and I, we will try to simplify the complicated, very abstract thing into a more visualized way. So, for example, one time I have a conversation with a student and we talk about the PubSub model, the publication subscriber model of the Ros, and we use this and we use a lot of analogy and about how there's like a middleman like handling data around, and right after that the student can understand very, very deeply, and she can get into writing the code very comfortably. And also a lot of students here, they have some programming experience before, but by writing computer programs, we only limited to the terminal, the input output. But this time the student can actually working with a simulation environment, and they can think about the robot as an object, and they can do those object-oriented programming on it, and they can understand a lot of like previously more abstract concepts, algorithms with this more visualized way. So it's actually benefit from the both sides. So student can see it, because student can see it, so they can understand better. And because they can see it, they can understand some of the previous more abstract concepts better. Yeah.
Thank you.
Mhm.
Yep.
Okay,
Any other-
I have
Go ahead.
just one hack question. So from the presentation, the class is on a Monday morning, right? So what if the student cannot attend the class due to the unexpected reason, like the tournament, other tournament game
Yeah.
or family plan? So we
I can-
will regard the
Yeah.
class.
I can answer
Okay.
for that. It's the same
Mhm.
policy for every XCamp, because this is XCamp offered class. So same policy, every class will be recorded. And the recording will be posted in the Google Classroom together with the presentation, the course lecture, all the material will be there. And for any students who could not make the class, they are mandatory to take the recording session after the class was done, and they have to finish the homework in the lab. So to answer your question, yeah, we do have students miss class because they're super busy, but every class is recorded. They should be able to catch it up.
Okay, got you. Thank you.
You're
And
welcome.
also we have the lab session. So
Mhm.
different from EdCamp, EdCamp because the program is run here, not kids configure yourself. For robotics, we make the lab hours 2 hours, and then teacher or TA will be in the TA hour for 2 hours. So in case your student miss the lecture, watch the video, then come to the TA the lab session.
Yeah.
Okay, got you. Thank you.
Mhm. Any other questions? We can take one more because we are 10 minutes over. If not, we will close this info session. Please let us know if you have any questions. Like I said, we'll schedule another final project presentation presented by our students after this class is finished. So we'll send that information out again to the parents. And if you have any questions, please feel free to email XCamp or just reach out to us. We're happy to answer any questions. And with that, I will thank you everybody who's here tonight. And also thank you, great big thank to Mr. Chen and Yi Chen and our students, Rory, for coming here for the info session. Have a good night, and I will send the recording session shortly. Thank you. Bye.
Thank you. Okay, bye-bye.
Thank you. Bye.